Hello everyone. In this video, we will study number of very important global trends in constructing and developing science curricula. Let's start by asking you, do you believe that education is a preparation for exam? Or do you believe that education is a preparation for life? Or we can consider education as life itself? We can say that the STEM global movement depends on John Dewey's ideas about education. John Dewey was known as the father of the progressive education and was an advocate of social learning. According to John Dewey, education is not preparation for life. Education is life itself. Dewey pointed out that science teaching has suffered because science has been so frequently presented as so much ready-made knowledge, so much subject matter of fact and law, rather than as effective methods of inquiry into any subject matter. In 1896, John Dewey started an experimental school at the University of Chicago to test ideas and teach children. The school was designed to exhibit and conduct research in educational methods centering on the child. Lessons featuring collaborative hands-on activities replaced the traditional instructional method of drill and memorization. In 1993, the National Science Foundation began to use the acronym SMIT as a shorthand of science, mathematics, engineering, and technology. The first letters of these four pillars was arranged to reflect the idea of using science and math to understand something, and then using engineering and technology to do something about it. The term STEM was first suggested by Professor Judith Ramley in 2001 when she was the director of the National Science Foundation's Education and Human Resources Division. Ramley said, "I didn't like the sound of Smith word." She suggested STEM as an alternative which sounds better and easier to both remember and pass. In 2006, President Bush, in his State of Union address, he spoke of the need to support and grow the job market of the STEM fields, pure science, computer science, statistics, and mathematics. And by 2008, STEM started showing up in headlines, and this is an indication that it had become common educational term. Science education scholars emphasize the significance of an integrative interdisciplinary STEM, science, technology, engineering, and mathematics, that encourages students to learn about the natural world through exploration, inquiry, and problem-solving experiences. Over the past several decades, there has been a growing interest in STEM education, particularly in effective strategies to prepare students for advanced study in STEM related fields. Now we want to differentiate between science, technology, engineering, and math. Science is the systematic study of the natural world. It begins with a question about a natural phenomena. Engineering is the use of scientific principles to design and build machines, structures, and other items in order to control the natural world. It starts with a problem facing humans. Technology uses the devices, tools, processes designed by engineers to increase our comfort and abilities. Mathematics is a science of patterns and relationships that help human to understand and solve problems that originate in the world around us. To clarify the difference between the four terms, we can say that the science and math study the stimulated emission phenomenon. Engineering apply the scientific knowledge about this phenomenon to design laser cutting machine. technology use the laser cutting machine to solve problems in the fields of medicine, industry, and scientific research. The presented figure demonstrates how the four components of STEM, which are science, technology, engineering, and mathematics, work together towards fulfilling the societal needs. As you see, science and mathematician generate scientific and mathematical knowledge, which used by engineers and technologists to design and provide technology and engineering products, which used to support the scientist and mathematician again. All these processes help in satisfying the needs of the society. The core feature of STEM is the use of knowledge to solve daily problems, making the learning of science, technology, engineering, and math more meaningful. STEM literacy has been defined as knowledge, attitudes, skills, and values to identify questions and problems in life situations, explain the natural and design world, and draw evidence-based conclusions about STEM-related issues. The presented figures show the levels of achieving the integration between the STEM domains. It starts with the disciplinary approach in which students learn concepts and skills separately in each discipline, and I think that the integration doesn't exist in this level. The next level is the multidisciplinary approach in which students learn concepts and skills separately in each discipline, but in reference to a common theme. This approach uses the theme that appears in each STEM and core course during the same time period to draw connections among subjects. The subjects, however, may be taught separately and the connections are made through teacher and students reflection. The third level is the interdisciplinary approach, which achieves a higher level of integration across subjects. For example, by focusing on a shared concept such as cause and effect. The fourth level is the transdisciplinary approach. This approach goes further than interdisciplinary by seeking fully dissolve the boundaries between the disciplines, and it organizes learning around the construction of meaning in the context of the real problem or themes. The last and the most important level is the new disciplinary approach, in which students fully embrace themselves in authentic real-world problem-solving tasks and address them using and developing appropriate skills in combination that, in a real-world sense, discard the traditional silos of disciplines. Because of the importance of STEM education, it has transferred to different countries all over the world like Finland, China, Australia, South Korea, Japan. These countries present an outstanding examples in STEM. For example, the South Korean program for building participation and achievement in STEM has incorporated the arts to strengthen the focus on creativity and design. This program is titled STEAM. In this video, we have studied the history of STEM and defined the components of the STEM: science, technology, engineering, and mathematics, and the relation between these four components and society. We discussed the importance of STEM education, and we presented some outstanding examples in STEM education in different countries. Thank you for your attention. I wish you all the best.